Hello everyone, welcome to our presentation titled BEEXPERT, voice-based chatbot with retrieval augmented generation for personal high school mathematics tutors. This research was conducted by several authors from Binus University. The authors of this study are Miss Angeline Marie Marcella, Mr. Novel Haryansa, Mr. Nathaniel Chandra, Mr. Rio Sutoyo, Miss Ubaidah, Mr. Dennis Alexander, and Mr. Andri Chawanda. Each of us contribute to this research with a shared goal of addressing challenges in high school mathematics education through innovative technology. Let's move on to the introduction. Currently, traditional learning struggles to accommodate individual learning pace due to time constraint and a generalized approach. Hence, AI chatbot have gained popularity to bridge this gap. But existing research highlights several challenges in personal mathematics education. Traditional LLM-based chatbots often hallucinate, generating misleading data. In addition, the provided direct answer hinders students to think critically. And finally, text-based chatbots are lack of interaction. Our research focused on the following question. First, how can hallucination be prevented on the LLM-based chatbot? And finally, how to design an interactive and teacher-like chatbot. So, this study aims to create a voice-based machine learning chatbot employing GPT-4o with customized prompt and retrieval augmented generation, or RAG for short, for interactive and guided instruction.
Next, I'm going to explain the methodology we use to develop the voice-based chatbot and the evaluation procedure. Here is the example of the chatbot interface where user can interact with the chatbot by speech. And these figures show the complex system behind the interface. At first, we prepared the retrieval augmented generation system by gathering learning materials from OpenWebMath, consisting of pairs of web URL and their content. Then the text is chunked, converted into numerical representation, and indexed using the BGE M3 model. The processed data is then stored in the Supabase vector database. The RRJ process will only be triggered when the user asks for a learning resource. When it is triggered, the system will perform a similarity search between the query and the passage in the database. Then the retrieved data is passed to the LLM to generate the final output. On the other hand, if the user doesn't ask for additional resource, the response of the chatbot will be purely generated by the GPT-4o large language model itself. The final output is then converted into speech using Azure AI and displayed on the web application. After developing the chatbot, we evaluate the retrieval augmented generation architecture using the following methodology. First, we generate 498 context-based Q&A pairs from the vector database. Then, the questions from the Q&A pairs are filtered based on the groundedness, relevance, and standalone scores. The Q&A pairs will be discarded if all scores are less than 4. Otherwise, the answers of the Q&A pairs will be further evaluated using the Prometheus LLM. Lastly, the Prometheus scores are analyzed. Additionally, we assessed the chatbot feasibility by asking a math expert to evaluate the content of our chatbot using our custom questionnaire. Meanwhile, we asked an AI expert and several randomly selected evaluators to assess the chatbot usability using the Godspeed questionnaire series and a custom questionnaire.
Now we're moving on to results and discussions. This graph shows the right evaluation scores across 3 categories: correctness, faithfulness, and relevance. Starting with the correctness, we see a strong performance with a score of 72.98%, indicating that the responses are generally more accurate. However, there is room for improvement in terms of precision and consistency. Next, faithfulness scored 31.91%, which is significantly lower. So this indicates that only 30 pairs strictly adhered to the retrieved context, while 64 did not, highlighting the need to enhance alignment with the provided information. And then finally, there is relevance scored 47.87%, showing a more balanced performance. So out of the total pairs, 45 align with the intent of the questions, while 49 missed the mark. So overall, this evaluation reveals areas where the RAG system performs well and areas where further refinement is necessary. Also, it's worth noting that the Prometheus 7B version 2.0 model was used as the evaluator in this assessment. And then continuing with the results and discussion, this slide focuses on the Godspeed questionnaire series, scores, and evaluator feedback. So the chart illustrates three categories. First is anthropomorphism, which scored 75%. And then there's usability with a high score at 88%. And perceived intelligence scored 80%. These results highlight the strong usability and intelligence perceptions, though there's slightly lower performance in anthropomorphism. So in terms of content relevance, mathematics expert validated that the chatbot's trigonometry problems align with the high school curriculum. So this demonstrates the effectiveness of the educational content that we use. And then finally, evaluators provide valuable suggestions for the improvement, such as refinement to the prompts to enable more straightforward and concise explanations. And then second, there's implementing a clear canvas feature and keyboard shortcut for undo and redo actions. And then there's including the option for users to interact through the text in addition to the speech recognition, which could be explored as a future enhancement. So all these insights are pivotal for improving both the user experience and the system overall performance. So to conclude, based on the RAG evaluation, the system has demonstrated a notable performance with a 72.98 correctness, showing strong accuracy, 31.91% faithfulness, which is remains as a key area for improvement. And then there is a 47.87 relevance, indicating a moderate alignment with the intent. And then while challenges in faithfulness and relevance persist, the system, which is powered by GPT-4o, has shown adequate capabilities in reducing hallucinations, which is a positive sign for future development. So in terms of key findings, first is the system shows strong potential support to support personal study, making it valuable for educational purposes. And then moving forward, improving the system's performance will require focusing on the quality data sets, gathering user feedbacks, and collaborating with the subject matter experts to enhance both accuracy and usability. And then for the future direction for this research, first we aim to enhance the RAG system. This involves refining how the system retrieves and processes information, ensuring that it becomes even more efficient and precise in responding to the user queries. Next, introducing text-based interaction will be also a key focus. This feature is designed to create a more engaging user experience, allowing users to interact in a way that feels intuitive and responsive. And then finally, we plan to adapt the chatbot framework to accommodate additional academic subjects. Expanding scope will make it more versatile tool, capable of supporting broader range of educational needs. To wrap things up, I want to thank you all for your attention and engagement. If you'd like to explore more about our project and research, you can simply scan the QR code on the screen or visit the link provided. Feel free to reach out, learn more, and stay connected. And thank you once again.